again. We're back to our friends the fractions. Maybe you can get a little bit of enjoyment out of this because we're going to talk about reducing fractions today. And if you have a little trouble with fractions, maybe you might want to think about it as cutting them down to size. You know, showing them who's boss. Well, let's find out. To begin with, remember that numbers that we multiply together to get a product we call factors. Remember that? Factors? Now I want you to think about that for a second, because what we're going to be talking about first here to be able to do what we need to do is we're going to be talking about factorization. And I want you to think about that and see if you can kind of get a feel for the meaning. The word, when you put ization, I-Z-A-T-I-O on the end of a word, that kind of turns it into a verb. So there's going to be some process going on here. And it's a process about factoring. So what we're going to be talking about now is finding factors. If we're going to reduce fractions, we need to be able to find factors. And you'll understand that in a minute, but let's think about that as we go through here. Now, there are some rules for divisibility that, if you know, can help you with the process of finding factors. Now, back when you first started going to school and you learned how to count, 1, 2, 3, 4, 5, 6. After you learned how to count by ones, what do they teach you next? Okay, I hope that most of you are saying count it by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Well, let's take a look at those numbers. 2, 4, 6, 8, 10. Do you see anything that's the same about every one of those numbers? Maybe you won't know how to say it, but aren't they all even? Every one of those numbers is even. Well, those numbers, 2, 4, 6, 8, 10, came from multiplying the counting numbers that you learned first. 1, 2, 3, 4, 5. You multiply them by 2. So every one of these numbers has 2 as a factor. So whenever you look at a number and it's even, you know that 2 is a factor. Even, 2, a factor. Okay, I'll make that so it doesn't look like a Z. If you have an even number, 2 is a factor. You know that automatically. Okay, after you learned how to count by twos, then how did you learn how to count? You know what, I've actually had people tell me they learned how to count by threes, but I kind of doubt that, because I was in a meeting one time and the lady that was heading the discussion asked people about counting by threes. And so she had us all stand up and we started counting, and people were going 3, 6, 9, 12, 15, 18. And the further along we went, people were looking all over the place, and she said, I don't see those threes up there. Where are you getting them from? But we just don't know that. I don't think most people learn how to count by threes, but I do think we learn to count by fives. So let's count by fives and see what we get. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. Okay, let's write that list down. Now, we're only going to deal with every other one of these right now, because we want to know about each one of these numbers, the 5, the 15, the 25, the next one would be 35, 45. They all came about by multiplying 5 times some of these numbers up here. So if a number ends in 5, what's going to be a factor? Okay. Ends in 5, a factor. Okay, now let's take the rest of this group. We got 10, 20, 30. every one of those are part of that same group so that they have a factor of 5 in them, but there's something else, and we've talked about this before when we had numbers with 0 at the end. Remember where that came from? Came from multiplying by 10, 20, so on. So if a number ends in 0, what's going to be a factor? Absolutely. 10 is the factor. Okay, now this next rule, I'm not going to expect you to understand it. I'm just going to expect you to believe that it's true. The reason I don't expect you to understand it is because the first time I saw it, it was in a math book. I was working on my BS degree in mathematics. I read through that presentation that the guy gave 3 times before I had any idea what he was talking about. I finally got it clear in my mind what he was talking about, but he actually, and this is true, it's true, but it's going to be hard to understand. So I'm going to suggest on this one, you just learn the rule. Okay, if you have a number, and I'm just going to write one down here, like 117, the digits of that number are 1, 1, and 7. Is everybody clear on that? Okay, so the first thing we're going to do is we're going to add up those digits. So I'm going to go 1 plus 1 plus 7, and that equals 9. Okay, so if I get a number that I'm not sure about what factors might be, this is something I can try. It may not work, but it might, so we try it. When I add up those digits, if the sum is divisible by 3, the number is divisible by 3. If the sum is divisible by 9, the number is divisible by 9. Now remember, you have this video to watch. You also have access to the notes, so you can look at the notes and follow along with them. But find the sum. If the sum is divisible by 3, the number is. If the sum is divisible by 9, the number is. So, in this case, this number 117, we added up the digits, we got 9. Well, 9 is divisible by 3, and it's also divisible by 9. So that means that 3 and 9 are each factors of 117. Now that is handy. Imagine looking at 117 and trying to figure out what the factors might be. So we can find factors of 2, 5, 0, and 3 and 9 using these 4 rules. Now these rules are to help you when you're trying to do factorization, so you can look at a number and try to figure out what the factors might be. Okay? So if they don't work, then it could be, a factor could be a prime number. I mean, we've talked about 2, 3, 5, and 9. But it could be 7. And sometimes we just have to try if these rules don't work. But at least this gives us somewhere to start, so we don't have to just guess about everything. So it's really nice to know this information. Now, reducing fractions. Let's do that. Okay, first of all, we're going to talk about 4/8. And we want to show that it's the same thing as 1/2. Now visually, you can probably see that. I'll just draw a picture here really quickly. And remember, use your imagination. Okay, 4/8 would be 4 of those. And I'm going to draw a border around 4 of them. Can you look at that and see visually that 4/8 is the same as 1/2? Okay, so we can see that it is. Let's see mathematically why it is. So we take this 4/8. The first thing we're going to do is we're going to rewrite it a little bit differently. We're going to write this as 4 times 1 over 4 times 2. I didn't really change anything as far as the values go, because 4 times 1 is 4, and 4 times 2 is 8. I just wrote it a little bit differently. Now I'm going to take this thing and I'm going to break it apart. And I'm going to have 4 over 2 times 1 over, oh, better do it right. 4 over 4 times 1 over 2. Okay? But what's any number divided by itself? We just talked about multiplication. What is any number divided by itself? Okay, it's 1. So now I've got 1 times 1/2. But what do we get when we multiply any number by 1? That same number. So that is the way mathematically that we show that 4/8 is the same as 1/2. Now, I don't think it's necessary to go through all of those steps. I know mathematicians like to be precise and they might want to do that, but when we're trying to work with math just to be able to use it to find information we need, we don't need that. So let's see if we can find a different way to look at this. The thing, when it boils down to here, the thing that made this work for us, where we ended up with the 4 over the 4, was the fact that we had a 4 in the numerator and denominator. Now, let me say it the way the words say. We're multiplying 4 times 1 and 4 times 2. So 4 is a factor both of the numerator and the denominator. And when something is common to more than one thing, oh, I used the word, common. So 4 is a common factor of the numerator and denominator. The fact that it is a common factor, which allowed us to do this step where we had 4 over 4, and this step where we had the 1, and then 1 times the 1/2 gave us the 1/2. So we're going to cut this down just a little bit. When you want to reduce a fraction, if you can find a common factor in the numerator and denominator, we're going to say they cancel each other out. So what you could do to make this a little simpler, you start right here and you see that 4 is 4 times 1, 8 is 4 times 2. That common factor I can just cancel. Take it out. Okay? So that's how we reduce fractions. That's how we do factorization. We find common factors, and when there is a common factor in the numerator and denominator, we get to take that factor out. That's one nice thing about fractions. Get it, let out a little bit of your frustration because you know you get to take that factor out, that common factor. Okay, so the question might be, why do we want to do that? Why bother? Well, let me ask you this question. 339 678. How many of you got a clear picture of what 339 678 is? But what if I divide out a common factor of the numerator and denominator, which, by the way, happens to be 339, and I get 1/2? Which of those two is easier for you to visualize? 339 678 or 1/2? Is there anybody out there that said 339 678? Because I want to stay away from you. Okay? So we reduce fractions Because it makes it easier. And because even though it may not be perfect, if it makes it better, we're going to do it. So we reduce fractions regardless of how much difference it makes. If there's anything we can do to make it simpler, we do. We reduce the fractions. So the last thing you're going to be doing whenever you deal with any problem involving fractions is make sure it is reduced. And we don't just do this part way. And by the way, for those of you who don't know, this is called the Jenny Craig principle. We don't do this part way. When you reduce, you reduce. You do it all the way. You get out everything you can. When you get finished, there's nothing more that's common between the numerator and the denominator. So let's just take some practice here and see how we can do. We'll just do a couple of problems. We'll start with an easy one. 30 over 35. Now if you recognize, if you're clear enough on your numbers that you can recognize this to start with, then just start with what you know. Now they aren't both even. They don't both end in 5. One ends in 0, one ends in 5. I add up the digits. None of those 4 rules work for us here. Well, we don't give up. We don't curl up in the corner and in the fetal position, sucking on our thumb, moaning and complaining about how tough life is. We try something. I do know that that has a factor of 10 in it. So this is going to be 3 times 10. Now, that may be enough. That may be all I need, because now I can look and see common factors. Right off the bat, there's a 3 that's common. And since I hope we all know that 10 is equal to 5 times 2, then I can see that there's a common factor of 5. So I divide. Okay, back up. Let's do that right. See what happens when you don't pay attention. It's good for me to do this every once in a while to remind me that I got to pay attention, and it's good for you to see it so you understand what I say when I say pay attention. Okay, this is not 3 times 5, this is 35. I wasn't paying attention. So I'm looking now to see if I can see any common factors between these numbers up here, which I know. By the way, I know that one ends in 5. I could have made that one 7 times 5. Okay, now when I get the numbers smaller, and that's the whole idea of this, if I can get them smaller, maybe I can get to the point where I can tell what common factors are. And here, hopefully, we can see that there's a common factor between 5 and 10. So I divide the 5 out of there, and I divide the 5 out of there. So up here in my numerator, I have 3 times 2 left over, which is 6. In my denominator, I have 7 times 1, which is 7. And so 30 over 35 is the same as 6 out of 7. I used those rules to help get the numbers down to where I could handle them a little bit better. Okay, let's try another one. 60x squared over 12x. Okay, they have variables in there. Now I know that, but remember that variable is just a number. When you have numbers and variables together, let me suggest to you that what you want to do is look at the sign first, then do the numbers, then do the variables. So we're going to look at these two right here, the 60 and the 12. Now, at least they're both even. So I could take a factor of 2 out of each one, and I've got 30 over 6. Now at this point in time, I may see that, oh, wait a minute, 6 will go into 30, so there's a factor of 6. Over here, remember what exponents tell us? This says I have 2 factors of that number, whatever it is. Here I have 1 factor of that number, but it doesn't matter. As long as there's a common factor, I get to take it out. So I can take out this factor of x and one of those, and when I get finished, I'm left with 5x over 1. You don't have to put that one in there, but sometimes when you're getting comfortable, used to this, sometimes it's helpful to put it there so you can see what your brain just did, and it makes sense to it. So, we always reduce fractions, and we reduce them as far as we can go. Once we've done everything we can, then we let it go. We walk away. We don't need to do about it anymore. So, have fun, learn how to reduce fractions, take advantage of the help it'll be to you in doing some of the things you're going to have to do. And we'll see you again later.